In this lecture video, we'll talk about some key properties of complete graphs, which will help us in our conversation about traveling salesman problems. A complete graph is a simple graph in which the vertices are completely interconnected. Every vertex is connected to every other vertex. You can see 4 examples of complete graphs here. We have one with 3 vertices, 4 vertices, 5 vertices, and 6 vertices. We use the notation K sub n to denote the complete graph with n vertices. So this first complete graph with 3 vertices is K3. The second one with 4 vertices is K4. Then we have K5 and K6. Since each vertex is connected to every other vertex, that means that each vertex in Kn is connected to n-1 vertices, or has degree n-1. And if we have n vertices, each with degree n-1, n times n-1 is the sum of all the degrees. And with 2 vertices per edge, we have n times n-1 divided by 2 as the number of edges in Kn. The number of Hamilton paths in a complete graph with n vertices is n factorial. That's the product of all integers from 1 to n. The number of Hamilton circuits in a complete graph with n vertices is n-1 factorial. That's the product of all integers from 1 to n-1. Let's take a closer look at K5 for an example. This is K5. It's a simple graph with 5 vertices, and every vertex is connected to every other vertex. Notice that every vertex has degree 4, because each vertex is connected to the other 4 vertices. The number of edges for K5 is equal to 5 times 5 minus 1 divided by 2. That's 5 times 4 over 2, or 10. There's 10 edges in K5. Let's also calculate the number of Hamilton paths and Hamilton circuits. The number of Hamilton paths is equal to n factorial, and in this case, our n is 5. So we have 5 factorial Hamilton paths. That's 1 times 2 times 3 times 4 times 5, or 120. There's 120 Hamilton paths. The number of Hamilton circuits is equal to n-1 factorial. With n equal to 5, we have 5 minus 1 factorial Hamilton circuits, or 4 factorial. That's 1 times 2 times 3 times 4, or 24 Hamilton circuits. And those are the key properties of complete graphs, which will help us as we discover properties of the traveling salesman problem.